So Unit 6, Lesson 1, Periodic Function Properties. There are many situations in real life that repeat in cycles. For example, tides, daylight hours, temperature for the year, heartbeat, volume of air in lungs, rides on Ferris wheels. The list can go on. This trend that repeats in cycles is called a periodic phenomenon. The length of the cycle is called the period. The average value of peaks and troughs is the axis of the function, and the distance from the axis to the maximum or from the axis to the minimum is called the amplitude. So I did a little visual of that in the previous video. So this is what a periodic function can look like, and we looked at the sinusoidal, the sine function, the cosine function, okay? So here we're going to go through each of the equations. So let's go through the period. So when we're talking about like a cycle, we're going to pick 2 points that are in the same place of the adjacent angles. So the equation associated with that is when you're trying to calculate the period of the function, you're going to do a right point, and you're going to take the x of the right point, and you're going to subtract it by the x of the left point. Note that the period will always be a positive value. Next, let's take a look at the axis. So if you want the visual for a second, so we're saying that the period is right here. So if you start off at 0 and you go to 360 degrees, well, I'm basically doing 360 minus the 0 right here, and I will get 360 as my period. The next part was the axis. So the axis is going to be, well, it's going to be max plus min divided by 2, because if you do 1 minus 1, which is 0, 0 divided by 2 is 0, you're taking the average of basically where is this curve oscillating around, and the formula therefore is axis is equal to max plus min divided by 2. Next, we have the amplitude. So the amplitude was when you look at your axis and then you make your way up to your max. And so calculation-wise, what you're doing is max minus axis. Another way you can think of it is axis minus min. And another way to think about it is max minus min divided by 2. So there are 3 versions of how you can calculate the amplitude. And depending on the information given, it's going to determine which of the 3 you're going to use. So let's look at that graph for a sec. You had max minus axis, so 1 minus 0 is 1. Axis is 0, well 0 minus 1 is 1. You're getting amplitude of 1 every time, and notice that it's a positive number. Lastly, you can do 1 minus 1, which is 2, so the total part is 2. And then you do 2 divided by 2, so 2 divided by 2 is 1, and so you have an amplitude of 1. Lastly, we have the range. So the range is going to be, well, where does my y exist? So it's going to be y elements of reals. You have minimum, and it's going to be my smallest, the lowest value that I have is going to be my minimum y value, and it's going to include that value, and y is going to be a bit bigger than that, and it's going to be a little less than the max. So for question 2, after the sun rises, its angle of elevation increases rapidly at first and more slowly, reaching a maximum in 26 weeks. Then the angle decreases until the sunset.
So for this place on Earth, this is what the angle of elevation looks like depending on the number of weeks you're at. So one way that you could tell is that if you were to continue this trend, it will likely follow this periodic trend. And so that's one way to check. Another way to check is if this graph happened to show more than one cycle, then you could have done a check to make sure that the periods were going to be equal with these multi-cycles. But for this question, it seems like there's one cycle given, and I can see that based on like the number of weeks, and if I was to extend this trend will likely continue because I'll have like a mirrored image over there. Therefore, I would say yes, it follows a periodic trend, as the trend would likely continue. So let's take a look at question B. If you really further interpret this graph doesn't really make sense if you think of it in terms of Canada. This is saying that basically you have like a sunrise time, and this reflects like the daytime, and you are basically in night mode for most or half of the year. So what that means is that you are dealing with somewhere on Earth where you're in night mode, nighttime, and it's going to be very dark months for half the year and pretty bright for the rest of the year. And so the only place in the world where that is basically the North Pole, where it's approximately dark for half the year. And so in terms of actually answering this question, if I take a look at this highlight, basically it's bright and then it turns dark at -14 and then it turns bright again at 14. And so when does the sunrise occur at this time of the year for this particular spot on Earth? So I can say that if our point of reference is 0, then 14 weeks from now, that's when the sunrise will occur. Question C, what is a period? What does it represent, and what is longer, the night or the day for this situation? So remember, I had to recognize that this is one period, and that's why it is important that you understand what the sine theta and cos theta looks like, because then in my head I could be like, oh, this one looks like the cos theta, and so I could say, oh, it does reflect one cycle. The reason why that helps is, well, I could say, well, from here to here, that reflects like a negative sine theta, but then it's not quite done. So for me, it looks kind of like a cos theta, and it looks like one cycle. It starts and finishes there. And so in terms of finding out my period, it's going to start there and end here. And you're going to look at the x value when you're figuring out the period. So P is equal to right point x minus left point x. So what I'm doing is I'm going to do 26 minus 26 to get the answer, which is equal to 52 weeks, which works out to be 1 year. So in total, my one period is equal to 1 year. But that wasn't the end of the question. They asked how long is nighttime and how long is daytime in terms of like the number of weeks. And so if you look at the gray parts, so what I'm doing is, okay, from here to here, that's 14. From here to here, that's also 14. When I talk about duration of time, I'm going to talk about it as 28 weeks. So I'm really adding 14 plus 14. Please don't get 0 as your answer, right? Because like we're talking about the duration of time. So 28 weeks, that's how long nighttime is. Whereas for daytime, it's going to be the other parts. So the magnitude or the scale between -26 and -14 is the number 12. So 12 plus 12 is equal to 24. So I'm going to write 24 weeks. Okay, so I stepped outside, so hopefully you don't hear. So I stepped outside for a second because it's so much nicer outside. I hope you don't hear random sounds, but you might hear some bird sounds. All right, question D. What is the axis? What does it represent? So the axis, so this is where the curve goes around, right? And so it's going to be somewhere between the max or min, and it's kind of hard to tell where the max and min is. So I'm going to tell you that this coordinate is negative 26, 58. You would have to look in, zoom in very closely to figure that out. And I also need my min value. So this is my minimum value, and this is 0, negative 60. So in terms of the graph I'm given, these are my max and these are my min. So the equation for the axis is equal to max plus min divided by 2. So when I plug in the y value and not the x value, and it's really important that you pay attention to where do I put y versus x, because this was in terms of x and this is in terms of y, and rather than memorizing, try to understand the situation. That had to deal with time. This has to do with my y values, so that's why I'm comparing the y values. So 58 plus negative 62. I'm just going to fix that up so that it says negative 62. Because it's slightly below the negative 60. And so I'm going to get 58 minus 62 divided by 2. In the numerator, I have a negative 4. So negative 4 divided by 2 is negative 2. And what does this axis mean in terms of this question? So it's the average angle of the sum. And when we draw it out, it's going to occur at approximately x equals negative 2, which is going to run along here. And actually, no, its axis is equal to y equals negative 2. Don't mess up on that because this is where my y value is, right? My x equals negative 2 is over there. This is my y equals negative 2. For question E, what is the amplitude? What does it represent? So amplitude, there are different versions of this. So you kind of use the one that makes sense in that for that question. But I had my max value and my axis value in this case, so I already had to figure that out. So I could use this version, which was like the first equation that was given over there. So when I plug in, I'm going to get amplitude is equal to 58. And I'm going to do 58 minus the axis, which is going to get me to do minus 2, which is equal to 60. So if you notice, there's like a lot of equations involved. So rather than focusing on equations, I really like looking at the graph and then maybe making your equation based on it, right? Period is, well, how long is it from one coordinate to the other, making sure that you are making a full cycle. For axis, well, you want to get the middle of your max and min, so you have to add and then divide by 2. For amplitude, well, it's going to be distance between your max and your axis, or your axis to the minimum, or your max and minimum, and then you divide by 2 so you can get the halfway point. And so when I draw it out, it's basically from here all the way to there. what is the range? Well, range you've seen before, right? It's where does the y values exist, and if I take a look at the graph, it's gonna be somewhere like from there to the bottom, and that is the range. Basically from your minimum to your max, and we didn't have to look at that formula for that, right? So range is equal to y elements of reals, and just recall our minimum and maximum number, and it was between -62, and y is going to be bigger and including -62, but it's going to be less than +58. And what it means in terms of this question, because it's a word problem, you have to interpret it. So it's the possible angles of elevation of the sum. So for question G, you're asked to extrapolate and interpolate. So those are some terms that briefly came up in grade 9, but very forgetful words. All that means is that for extrapolate, you basically extend your graph beyond what's available, and you based on the graph, you try to estimate where your values are. Whereas interpolate means you have the value within the graph, and you're going to determine your value based on that. So you go beyond the data, and what you're basically doing is trying to draw a graph that looks the same. Okay, so I kind of did this in advance, and I'm not sure if it's going to work perfectly because, yeah, it's an estimate, and the numbers might not work perfectly, but that's a 28 because everything was jumping by 2s. See how it's like 2, 4, 6, 8, 10, 12, 14. So that means it's 28, about 30, 32, 34, 36. So basically at 32, which is 28, 30, 32, somewhere over there, it's going to be a coordinate around there. So you're dealing with a value somewhere between 40 and 30. And honestly, during my first version, I got a number close to 37, 38. This time it looks like more like 32, 33, but as long as you're giving me values where it makes sense, like it's within 42 to maybe 28, because we are estimating when we extrapolate, that should be okay. Unless they say to find the exact one by using the sinusoidal function itself. It's going to occur at about 38 degrees. And in terms of the second question with the interpolate, let's take a look at 12 weeks. Well, that's interpolating, so my values will probably be more exact because I don't have to freehand draw my new graph. So at 12 weeks, lining it up, I have a value of approximately negative like 18 degrees. So this is what I get for question G. So when I extrapolated, I got about 38 degrees, and I got about negative 18 degrees when I interpolated. So H, during the what weeks is the angle of elevation of the sun above 30 degrees? Maybe I'll make a line just to show you where we should be looking at. Positive 30, which is right there. So if you take a look at the graph, and if my purple line is my point of reference, so I can try to take a look at exactly where is my graph above 30, I have a spot there and there. And so I have to write it down as, let's say, -26, from -26 including to whatever this value is, which is approximately negative 18.1, because it's like not quite at negative 18, but a little before that. And then the other part where it is above 30 degrees is it's like it's a symmetrical kind of shape, like a parabolic almost actually. And so it's beyond 18.1, but not yet and including 26, if we're thinking about it in terms of one cycle. Say that the domain where this is true is exactly what I said verbally. So from negative 26 and including and up to negative 18.1 approximately, and then it's symmetrical, so 18.1 to 26. And I'm just going to erase one part. I'm going to erase the ones where it says including, because if you look at the graph, it says where is it above, not above and including 30 degrees. And so I'm not going to include these for that reason.